let's talk about JavaScript. This is an introductory course to JavaScript. As you would already know, in case you don't know, is that TypeScript is a layer on top of JavaScript. If you are coming from a JavaScript background, you already know that you don't need to specify any type when using JavaScript. So, for example, when you want to declare, say, for example, constant a equal to something, you don't need to specify if it is a number or a boolean. It automatically knows that you are saying that I am a boolean or I am not, something like that. But when it comes to TypeScript, it helps you to specify exactly what you want and how that program should be. So one could be wondering, why this extra step in building our application? So the thing is, TypeScript helps you to find out error at runtime. Even while still writing code, you can fish out all bugs possible, and you would be able to write better code. You'll be able to collaborate better with fellow developers because there is a standard that you set and all that. So there's so many benefits for using TypeScript. And so we'll just get started. It's not going to be a long tutorial. This is a basic introduction to get you started with TypeScript. Everything you really need to know and you use in almost everyday life as a developer. That's what we'll be covering here. You might find out a few other things as time passes by. But let's jump right in. So like I said, this is a layer on top of JavaScript. So if you've not seen my JavaScript tutorial, please check it out. Everything we'll be doing here will just be how to set up types. But if you're thinking about JavaScript proper, I already covered that tutorial in a previous video, so please check it out. And here's the curriculum from that previous video. Everything you need to know about JavaScript was properly covered, and that is it. Let's jump back into TypeScript. Now for this, we'll move to TypeScript lang.org. This is the official website of TypeScript. So we'll not be setting this up in any file. You could choose to set this up in a file. So for example, when you click on try TypeScript now here on this page, it takes you to a place where you can either try it in your browser or you can try it on your computer, which means you have to install this, download this, install it anyhow through npm yarn or pmp, however way you choose to. There's so many instructions here, but like I said, what I just want to do is introduce you to what TypeScript is all about and see how you can add it to your already built code. So because of that, we'll just use the TypeScript playground here. Really interesting. I've played with it before. As you can see, my name is already there. I'll just make sure to zoom in or zoom out a bit, I don't know. And here's another cool thing about using this playground. It transpiles immediately for you so that you can see everything that is going on. So for example, when you write in TypeScript, it automatically transpiles it to regular JavaScript, anything below ES6. So we are looking at ES20, 15 below, something like that. So here is a basic code in a TypeScript, and here we are declaring a. But instead of doing what we'll have done normally, so in JavaScript, this is what we'll have done. We'll just do a equal to Samson, and then we can run the code, and of course it will still run. But here we can now declare a layer of type. So this would also run, but the difference here is that you cannot reassign this even if you wanted to. So let's do a let. So when I say reassign, I mean you can't change the type. So let's use a let, and this will still run, right? But how about if we want to change this to a number? So let's say a equal to 100, something like this. So let's make sure this works as it should be. And so even from the editor here, it's already telling us that type number is not assignable to a type string. So this is the cool thing about TypeScript. You will not unknowingly reassign something, a different data type, to another data type. So it has to be a string. So you see, as soon as we convert it to a string, our editor here stops yelling at us. So that is it. And so let's get started immediately, properly, as we follow through with our curriculum here. All right. So this is curriculum. All right. Now in the types, we've already touched on to number and string in our demonstration. We could, touch more on this stuff. So let me just copy it and we'll comment it out like this. So this is what we want to cover, and let me make sure to move this to this side. So we already pointed on number, and we already pointed at string. How about if you want to declare a boolean? So if you want to declare a boolean, you could just say is man, something like that, equivalent to. So we make this equivalent to true. All right, and you can log it to the console if you choose to, console.log, and say isman, like that. So when you check out isman, it gives you true, but we didn't specify, and so for us to specify, we need to add that, hey, this is a boolean. All right, so this is how you specify for a boolean. If it goes beyond this, some people would use any. So what is any for? So when you put any, it's as though you didn't put anything. So ordinarily, when you don't put anything, it will take up or infer what you are saying based on the value you have assigned it. But when you specify what it should be, then you can't assign something else. So for example, if I have made this a boolean, and then I try to give this a string, you see I'm already getting an error telling me that string is not assignable to a type boolean. But if I put any here, then it wouldn't matter because any value would go. But this is really dangerous, and it's really discouraged. As much as possible, you shouldn't use it. So it is even better that you use something like unknown, which is the next data type that we want to talk about. So using unknown, yes, shows that you don't know the specific type at the moment, but you would assign this later. So at a later time, you could choose to say something like, okay, isman as a string, sorry, something like this. All right. So when you check the type of I think type should work here. Type of isman, it should give you a string. You see, it gives us a string. So we can clear this off. Let's clear up the log. So when we run this, it gives us a type of string, showing that it has been casted to a string. We'll talk about this a little more as we continue. Then we have type of undefined, and we have type of null. So these are basically types that don't really refer to anything or things you hardly use. But just know that this type exists, and there's some other type that exists. So after covering this, the next thing we want to look at is array. So the type of array. So let's clear this and say we are looking at array at this moment. All right. All right. So let's say names, and we want this array to be, array of names. So we have Sam, we have Ebere, and we have Njoku, like that. So when you check when we try to, sorry, we have not even assigned. So let's assign what it should be. So how do you declare this array? What is a particular type? Now for this, there are two ways you can specify. So first of all, you can choose to say that, hey, this is an array like this, but you also need to specify what that array would contain. So you could see from here, it's telling you that this is a generic type, that it requires that you pass in what it should contain. So you could just pass in here string, and so once you pass in string, it stops yelling at you. So this means that this is an array of string. Now you could also make this an array of number, like this, but notice that immediately we make it an array of number. It shows that what we've passed here is wrong. So this is how you declare an array. But another way you could also declare an array would be to specify the types that it will be containing, then also specify that this is going to be an array. So you see, as soon as we add that the two square brackets, then the error is gone, and we have our clean array. So we could check our array and see what happens here. So once we run it, you see it's showing us everything as it should be. So this is how we declare an array. How about an object? How do you declare an object? So for you to declare an object, you follow similar pattern. So to declare it, let's go back like this. Let's say let's make this person, something like that. So a person, and then we want this to be a key value pair, whereby the key is maybe a string and the maybe the value could also be a string. So let's do something like this, and then let's say name equal to Sam, age equal to 24. So let's make this a string. We want everything to be a string. We could add something like address, and then we say Nigeria. So make sure to put this instead of a string. So like this. So this is an object, but how do you specify exactly how the object should be structured? So you come to the person here, and then you specify by saying something like record. So record, and then inside of here you specify how you want it to be. So you want it to be string. This should be a comma, by the way, not a colon. So string, which means that you expect that both the key and the value should be a string, like that. All right, something like this. You see, as soon as you get this, it works. If we change this to a number, then you see we are getting an error all through. So for this not to be an error, we need to change everything here to a number. So for example, we change this to a 1. You notice that name is no longer yelling, to age to a 2, and then change this to a 4, and everything is working perfectly as we would want it. All right, so this is how you declare it. But another way you could declare this would be to use something like a curly brace like this, and here you specify what the key should be. So key of a string, and then this outside of it here you also specify that okay, you want this to be a number, like so. So once you do it this way, you see the editor isn't yelling. It shows that you specify that you want the key to be a string and the value of the key to be a number, just like that. So this is how you declare an object. All right, so we can check these types off and say these two are off our list. So now we go to inference. So inference means inferring or assuming something without being told what exactly it is. So for example, let's say we set person here to maybe my name Sam, and we decide to check which type. So you notice that at this point we didn't specify any type, but if you hover on top of it, it tells us that this is a person of string, and when you check the type of it, it's also going to tell us that it's a person of string. It follows similar patterns. So give me a minute. Okay. All right. So it follows similar pattern in any other thing that you are declaring. As long as you don't specify the type, it's going to infer whatever type that you've given. If I change this and make this an array and hover on top of it, you see it's telling us that this is an array of string because that is what you passed in. And if I add maybe a number here and hover on it, you see it's telling us that this is an array of string and numbers. Do you see? An array of string and numbers. Now I didn't teach this at the previous part, but I think we're going to still reach to it. But you can combine types, just in case I don't touch on this again. Just know that if you would like to specify multiple types of an array, you can do it. So you could just do something like array, and then inside of the angular brackets here you could declare like a string and put a number, and you can even add a boolean, something like this. So this means that anything ranging from a string, number, and boolean would all work here, as long as you don't add something else that would create a bug. So you see, immediately we try to add an object, it's already creating a bug for us, so we need to get rid of it. So I think I've been able to cover what inference really mean. Sometimes when you declare things like this and you hover on it, you notice it's telling you any. Now this means that this is of the any type, anything can be assigned to it and it's going to work. So this is what inference is all about. So we can check that off from our list. So far we have been seeing an inline type that we've been declaring, ranging from when we declared for the array. We used a one-liner like this to declare for the array. When we also declared for like the object, we also used a one-liner, like this, declaring it just the way you are saying it. But sometimes it might really get complex, and you want to specify a more detailed type different from what you already have. Now that is where the type keyword really comes into play. So let's look at the type keyword and interface keyword. Now these most times can be used interchangeably, but they differ in their different ways. So let's get to it. So I imagine you want to specify or declare a kind of object where every part of the object is really different from the other. So let's say something like we want to declare a test object where there is a name, there is an age, there is a condition, there is whether this person is married or not, stuff like that. So let's see how to declare. So the first thing you need to do is use a type. So this is showing that what you're about to do is not just a variable but a type. All right, then you want to specify that this is a person type. So you can name this anything that you choose to. Just make sure you remember it. Then it's going to be equal to curly brace, like it's an object. And then when you open it like so, you want to declare everything that is necessary inside of it. So for example, you want to declare the name and specify that this is a string. You want to declare the age, and you specify that the age should be a number, like that. You want to specify is married or is single, whatever way, and specify that this one should be a Boolean. All right, something like this. So you could specify as many types as possible. You could also specify things like skills and make this maybe a Boolean. Sorry, you could actually make this an object, something like that. All right, maybe you want to declare the skill, so this could be an array, something like this, where it could be an array of number. So you could just do an array of number, something like this. All right, then you could specify something else, like if the person is married, spouse. So spouse, want to find out detail of the person's spouse. So for this you could use something like an object. So you could specify, say, record, and here you want it to be string comma string, so that is a key and value of string, something like this. So this is a more complex type that wouldn't look cool if we put it in here. So if you want to put this in here, not like it's not possible, but it doesn't look cool, so I'll have to override this and paste this. You see, so it's going to work, but it's not going to look cool. But we always want to look cool. So instead of this, what we need to do is to declare the person type like this, and then we now want to work with what we have here. All right, so here we'll now overwrite and say Sam. So as soon as you satisfy every condition, it's going to show that it is cool. So 30 is married, you can say true. How about skills? So we specified number. Technical skills should be text, a string, but let's just, for the purpose of this tutorial, just specify number. If you try to add a string, is going to give you an error. You see, as soon as you try to add a string, there's an error already, except we decide to say, okay, this can be either a number or a string, something like that, but let's keep it that way. Then for here, we want to declare something, so something like maybe the person's name, something like that, and you could say something like Amma, and what else can we could add address, something like that, address, and specify, you can say Nigeria, Nigeria, something like this. This is poorly spelled, so let's get rid of this. So something like this. So when you do this, you see it now makes sense, and it's cleaner if we declare it in this way. We can also declare very complex type instead of making our code look messed up. Now this differs a little bit from interface, but they will work exactly the same thing at this point. So this is interface. So if it's an interface, you would not be needing the equal to. You see where they differ a bit. So for the type, we needed to have an equal to here, but for the interface, you needed not to have an equal to. There's a lot you can learn inside of documentation, so I advise you check it out properly. Something else one can do, you could extend the interface. So for example, if you want to declare another interface and you want to build it on top of this, you could say some type, extends something like this, the person type. So what's going to happen here is that everything declared already in person type would be immediately added to the sum type. Then you can choose to now declare some other thing. So something like can drive, and you can specify if it's true or false, something like this. Sorry, let's use a Boolean. We could add something like is tall, and specify that, hey, this is also a Boolean, something like this, just something like this. So with this, you can really manipulate and see where it takes you to. Make sure you play around and see how far you can go. So initially I told you about the where you can declare more than one thing for a particular value or a particular variable. Sorry. So talked about the union types, but I think we've already talked about it. But briefly, let me just remind you what we mean when we talk about the union type. So I could get rid of most of this, right? So when we're talking about union type, we're just specifying that one thing can refer to more than one, or one particular variable can refer to more than one data type. All right. So for example, here we can specify that this can be a number or a string, like that, and we are saying that, hey, this is equal to maybe a string. So let's do a sum like this. It's number like this. So we didn't need the angular bracket, and we messed that up. So you see, now that we specify that this is a number or string, giving it a string wouldn't throw an error, and also giving it a number wouldn't throw an error, but giving it a Boolean like true would throw an error because none of this is accepted. So this is a union type. It brings two types together and allow a particular variable to take any of those value. So you could choose to say, okay, I want this to be person as string. Now we'll come back to what this means in a minute, but basically it's saying that this person should be seen as a string at this instance. In other instance, this person could be seen as a number. We'll call this alias. So since I am already talking about this, alias is supposed to be the next thing. All right, so let's check off union and go to alias. So alias is basically casting a particular thing, a particular variable, to a particular data type. So you see, now that I'm casting it to a number, it's not accepting because I have not set this to a number. So I need to specify that this is a number for it to accept the casting. So that is what alias mean. So at many cases, you might declare that you want number or string to be what a particular variable will take, but sometimes you might see through an error specifying that you need to satisfy both conditions. This happens in rare cases though. You need to specify at that point that person, you want that person to be a number at that time, because sometimes TypeScript just wants you to be really specific. And that concludes it with alias. So we'll check this off and move to function, how function works. So let's clear all of this and of course start all over. So we'll do a function, and then we want to say that this is an addition function. Addition, to spell that correctly, and then like this. You could also choose to make this an arrow function. Sorry, I'm already mistaking for an arrow function. All right. You could choose to make this an arrow function, and it's going to work just the same. So a comma b, and we want to return a plus b, something like this. It's already telling us that this parameter is implicitly any, which is not what we want. So let's see how these types work. All right. So for you to declare type here, you need to specify inside of here what you expect this number, this a to be, and we expect that it should be a number. Also, we expect that the b should be a number, like that, and then we expect that it should return for us a number, like so. So when you do this and you call on this function, then you see that it should work perfectly, and you see that we are able to fix most of the errors we are getting right from inside of our browser. So if we do a console.log at this point and pass in our addition function and put in like a 2 and a 3 there, this should give us 5. All right. So let's run this, and we get 5. All right. How about if we pass in a string? So pass in a string here and see that we are getting an error because it is requiring that this place be a number. It's already telling us that string is not assignable to a parameter of type number, like this. All right. Now, something else you can do or you need to know is that you could specify that a particular parameter is optional. So for you to do that, you just need to add a question mark in front of the parameter, like we are seeing. It's calling us for an error here, but it's telling us that this is possibly undefined. Yeah, because you are making an addition here, you cannot add a to an undefined, but I'm just specifying that this is how you could make anything optional, but you need to also satisfy other conditions. Now this might be easier if it's like a string or something like that, but this is basically how it works, and you can use this anywhere, even when declaring types. So that's it for functions for you. Just in case you will not be probably returning anything, you can just change here to void, something like this. But if you change here to void, you would also need to fix here. So that means you need to just put a return because it's not expecting anything, and also everything is clear. All right, so back here, the last thing we want to look at here are utility. Already we've used one of them, which is record, but we'll just quickly run through all of them in a minute. So for us to work on these utility types, let's go back to this point where we had types and interfaces declared. All right, so let me just get rid of the sum type interface, and so this should work for us, and this is what we are looking at. So we'll pick them one after the other. So let's just copy and put them at the top here, like so. So the first one is partial. So what does partial mean? So when we say that we are expecting that something should be partial, we mean we are not requiring all parts of this type. So here at this point, all this type or all parts of this type is required. If you don't put in anyone, for example, you get rid of name, you see person is already yelling saying that name is missing. All right, now but if we want to get rid of this error, we just add a question mark here, and it shows that name is now optional. As soon as you do that, the error is gone. But here is another standard way of doing it. You could come here and set partial like this and say that you don't mind this being partially assigned. So let's do person type. So when you do this, it means that you could get rid of anyone and the editor would not yell at you. So you see, I got rid of age and there's no problem. I could even make this empty and there'll be no problem. So this is what partial is all about. Now, but the required is the opposite of partial. So when it is required like this, so required, it means everything has to be there. So if I get rid of one, we'll get an error. If I get rid of any other one, we'll get an error. So that is it with partial and required. Now for omit basically means that you want to omit these particular keys out of this. So first of all, you need to change this to omit, omit. So when you specify omit, they will want you to specify other things that need to be removed. So what are those things we need to remove? We could specify any amount of keys. For example, we could specify that we want name to be out. So when you specify that we want name to be out, if you put in name here, is going to throw an error. You could also specify others. For example, you could specify that you want h2 to be out, like this, and you see that it's throwing an error. H2 is throwing an error. As soon as we get rid of all of this, it is fine with it. So that's omitting. So how about pick? So let's do a pick like this, and you see that as soon as we put in pick, it starts giving us an error. So what it means here is pick means I want only these two that I have entered here. So that means I need to get rid of everything here and specify only the name. So name could be maybe a bearer, and the age 34, like so, and you see the error is gone. So if I add in any other thing here, it is going to throw an error except I put it in, something like that. All right, then there is the read only. So what read only does, let me return this back to normal. So what read only does is it makes it impossible for you to reassign a record after you have put already initialized it. So read only like this. So once you make it like this, I need to also get rid of this part. So once you set this as read only, you cannot reassign this. So for example, I cannot do say person dot say age, and then I'll say it's equal to 90. It wouldn't work because this is read only. However, if I change this to any other thing like required, it's not going to mind. You see, it's not going to mind. So that is where read only comes to play, if we just want to declare it once and not reassign it. Now the last one is what we have used before. This is used to declare it's used to declare an object, how we want an object to be. So we've done this before. I don't think we should be doing it again, but it just follows this this pattern. So record like this, and then we specify that we want this to be a type of string, sorry, a key type of string, and a value type of maybe number, like this. Everything is going to throw an error aside from things that have only number as the value. So you see, so if you want to add something like this, you could do number of children. So something like children, and then you put the number of children, say 2, like that, and it's still going to work. So that is it. This is it for TypeScript. So like I told you, we're not going to be building anything special or building any project, because we've done all this in JavaScript. So in case you don't know about this, please check out my JavaScript course. Basically, what we've done here is how to quote or sugarcoat JavaScript. So we added types on top of JavaScript. This is a basic introduction to TypeScript and everything you really need to know. Thank you very much for watching. I'll see you in my next video.